In this section, we're going to cover codes and standards. If you're a safety manager, this is going to be especially valuable. Our end goal is safety, and we want to help you make that an everyday practice beyond compliance. But at the same time, safety managers have to make sure their facility meets all rules and regulations set by governing bodies. We're going to look at how OSHA and NFPA relate to one another. Talk about why the NFPA 70E is so important. We'll show you how you can use the current NFPA 70E handbook and run through standard updates too. There won't be any hands-on exercise in this portion of the training.
That partnership between OSHA and NFPA 70E is the reason we're all here. Electrical safety. OSHA is the governing body in charge of regulations and abatement. The NFPA 70E handles the technical side, including safe work practices. So basically, OSHA sets the rules for what compliance is, while the NFPA 70E shows us how to get there. For example, OSHA states, employees working in areas where there are potential electrical hazards shall be provided with and shall use electrical protective equipment that is appropriate for the specific parts of the body to be protected and for the work to be performed. 1910.335A1I. The NFPA 70E is going to look at that rule, figure out how to classify a potential electrical hazard, and determine the appropriate level of PPE. Based on that, the standard for compliance is set.
Here are some OSHA electrical safety standards every safety manager should know. 1910.331 covers scope. 1910.332, training. 1910.333, work practices. 1910.334, portable equipment. And 1910.335 covers protective equipment. From a compliance standpoint, electrical safety has improved leaps and bounds in the past decade. OSHA provides an excellent framework for discussion. So, how did the NFPA 70E come about? What makes them a trusted authority for protecting employees against electrical hazards? The NFPA 70E's first edition was released in 1979, but its roots go all the way back to 1896. That was the first time a national standard for electrical installation was set. The organization's main goal has always been the safe installation and operation of electrical equipment. In the 1970s, Congress passed the Occupational Safety and Health Act. This formalized the relationship, giving the NFPA congressional recognition as a major source for national consensus standards. 29 CFR Section 1910.3B1.
Now we'll talk about how to use the handbook. We can break it down into 5 sections. The introduction tells you why you need the manual, who should use it, and how to use the material. Chapter 1 holds the bulk of the information. This is the heart of the manual, covering safe work practices. Chapter 2 provides guidelines for maintenance on electrical equipment. Chapter 3 focuses on establishing safe work practices in unusual circumstances. And the informative annex section contains supplementary material that explains content in the previous chapters. So let's unpack those sections in more detail.
Inside Chapter 1, you'll find 5 articles. Article 100 is 29 pages. It covers definitions of fundamental technical terms used in the manual. Article 105 is 3 pages. It gives the framework for the rest of the chapter, details application of safety-related work practices and procedures, and identifies responsibilities for employer versus employee. Article 110 clocks in at 45 pages on the general requirements for safe work practices related to electricity. Article 120 is 27 pages. It is dedicated to one of the most effective life-saving tools the NFPA 70E provides, creating an electrically safe work condition. And finally, Article 130 at 70 pages, titled Work Involving Electrical Hazards. It covers everything like permits, assessments, PPE, overhead and underground lines. There's a section titled Other Precaution for Personnel Activities, and specifics on cutting and drilling near equipment or working with existing conductors. Now more on those articles, starting with 105.
Article 105 is the application of safety-related work practices and procedures. Let's hone in on the employer-employee responsibilities section. Simply put, the employer is responsible for safety training and the employee is responsible for putting safety into practice. It starts with the employer identifying and creating safe work practices, documenting those practices, and then clearly communicating them and training the team. As part of the training process, employers should ensure each worker demonstrates an ability to recognize and avoid hazards. Employees are responsible for complying with the standards set by the organization. Let's move on to Article 110. It's a lot more in-depth and covers the general requirement for safe work practices related to electricity.
There's a lot going on in 110. Electrically safe work condition, energized work, electrical safety program, hierarchy of risk control and priorities, job planning, lockout tagout, training, additional info on responsibilities, use of PPE and tools, portable equipment, and circuit protection. Qualified workers will spend a lot of time getting to know these topics. However, it's the safety manager's job to document the process and procedures for creating an electrically safe work condition and set the rules for when energized work is permitted. Electrically safe work conditions and energized work are at the forefront of the NFPA 70E's safety mission. You'll learn more about them in Article 120.
Remember that even though we're learning about codes and standards, there's a different reason why we're all here. Electrical safety is about making sure workers are ready to face challenges that appear in one moment so they can make it home safely at the end of the job. This message should be first and foremost for your team. Create an electrically safe work condition first, and if working energized, use insulated tools and wear PPE. So what makes an electrically safe work condition?
An electrically safe work condition is an equipment state where we have removed power, verified it's safe to work on, and protected ourselves from the equipment becoming re-energized while we're working on it. People mistakenly confuse lockout tagout for an electrically safe work condition. Though it is a crucial step in the creation process, lockout tagout alone is not a suitable replacement. Since this is a common misconception, we've created an acronym to help you remember the actual steps in creating an electrically safe work condition. LOCKS, squared tag. L stands for locate all possible sources of energy. O for open all required disconnects. C for check that disconnecting devices are fully open or drawn out. S stands for stored energy, and it's squared because there are two types of stored energy that need to be released, electrical and mechanical. T stands for tags and locks that should be applied to all protected devices for isolation. And A stands for absence of voltage should be verified using adequate rated test equipment. And G stands for grounds that should be safely applied in the area which you are working in.
The why behind an electrically safe work condition is simple. It saves lives. Production is not an adequate reason for working energized. If production isn't a good reason for working on live equipment, then what is? Let's look at a few cases where energized work is permitted. First, a situation when de-energization is deemed dangerous. By de-energizing the circuit, we introduce another hazard or increase the risk of another potential issue. Ventilation, chemical, mechanical, and environmental hazards should all be considered. Think about a medical facility that has life support equipment tied to a circuit. That's a justification for energized work. Second, it might be infeasible to remove power. Often this is due to equipment design or a task being performed. If so, the facility must document this, then energized work may be permitted. For example, if you require voltage for troubleshooting, energized work might be justifiable. New equipment and technology continually redefine what tasks are justified by the rule of infeasibility. Over time, new equipment design standards will play a critical role in removing workers from the hazard and risks associated with electricity. Third, is work being performed on AC circuits and equipment operating at less than 50 volts, where there is adequate upstream overcurrent protection? Lower voltages such as 12, 24, and 48 volts still might produce life-threatening explosions. The final justification for energized work involves equipment operation. This task focuses on opening and closing isolation and protective devices. The requirements for justifying this task are that the equipment has been properly installed and maintained. The doors are on, covers are closed, and there are no signs of impending failure. Equipment must be used for its OEM intended purpose, and the doors and covers must be secured. Most energized work scenarios require documented justification and safety protocols. Make sure you've identified the equipment and tasks that are allowed for energized work in your facility. This will help provide clarity to qualified workers when an electrically safe work condition is required. It's highly recommended for safety and EHS managers to have the latest NFPA 70E Handbook on hand. Getting to know the material will help make your facility a safer place to work. You can sign up for a membership at nfpa.org/registration to purchase access to the latest standards. But membership isn't required to buy a copy of the NFPA 70E documentation. To buy the codes, you simply visit nfpa.org and look under the Codes and Standards section for the Buy button. The material comes in two different forms, the Standard and the Handbook. The Standard is about 100 pages and details the basic direction of the NFPA 70E. The Handbook is almost 400 pages and includes explanations, examples, and graphics in each section. Most facilities purchase a copy of the Standard for each of the field staff and a single copy of the Handbook for the head of safety in the organization.
That wraps up our Codes and Standards section. There's a lot more material out there on electrical safety that can advance your facility's safety practices.
If you're currently implementing your own electrical safety program and administrative controls, use NFPA 70E resources during development and to stay current after you're done.